Hey, this is Math Minutes Pro with Dr. Harrison. Today, we will talk about how to rewrite exponential and logarithmic equations. Now, before we begin, let's take some time to talk a little bit about the concept of a logarithm, okay? That's what we're looking at right here. This is referred to as a logarithm equation, logarithmic equation. So logarithms are used to generally express very large and very small numbers as exponents. They are often used by engineers, scientists, and navigators to or other career persons to perform complex calculations. Now, the logarithm is actually referred to as the inverse function of an exponential expression like b to the x. So the way you read this logarithm right here is log base b of a, in that case. Log base b of a. That is the logarithm. Now this is an equation. It says log base b of a equals x. And of course, you know how to read the exponential portion here. That's our equation that says b to the x equals a. Now, the logarithm to base 10, which is written like this, log to base 10, is often called a common logarithm, okay? And we could say of a if I put that there. But that's a common logarithm when it has base 10. So I'm just giving you some foundational information here. Now remember, this video is an intro to the big idea of logarithms, okay? So we're just going to focus on rewriting exponential and logarithmic equations, but there's a whole lot more we can do with logarithms, and you'll see that in a different video. So we're going to go ahead and get started. We're going to practice writing rewriting an expression or an equation rather in exponential form, and we're going to rewrite it in logarithmic form. So let's go ahead and get started. So let's say I give you an equation in exponential form that says you have 7 raised to the second power. That's equal to 49. Now, before we get into that, let's come back and review the information up here, okay? So notice it says logarithmic functions and exponential functions are inverse functions of each other. Now, let's examine this right here. We have log of base b, log base b of a equals x. It says if and only if b raised to the x equals a. Now, look at this. There's some things that we need to notice here. Notice in this exponential portion, we have b, which is the base, and then you have b here, that's the base. You have this logarithm equal to x, and x is the exponent, so that means when you find the log of a number, you're really finding the exponent, okay? Like when you find the log base b of a, you're finding the exponent, right? That is that's raising base b, okay? When you find the log of a number, that's equal to x, and that is x in which you have raised base b, okay, where x is the exponent. And where it says log, it says here, log base b of a. of a. So a here equals what the exponential portion is equal to here. That's a. I always like to take time to explain this right here. So let's look at this example. We have log base 2 of 8 equals 3. Now remember, we said 3 is the exponent, just like you see here, and 2 is the base. So here we have 2 raised to the third power equals 8, which is when you're finding the log of a number. In this case, we're finding the log base b of 8, and 2 raised to the third power is 8. So now, we just want to make sure that we remember when you're dealing with this type of equation, b must be greater than 0 and b cannot be equal to 1, okay? So just keep that in mind. Well, I think we're doing great. We're going to go ahead and practice rewriting this exponential equation. So I'm going to draw an arrow this way. Remember, 7 is my base and 2 is the exponent. So then I rewrite it as log, right? Log base, there's my base 7, log base 7 of 49. That's what it's equal to there. So we're going to say of 49 equals, and what is the exponent? 2. There it is. All right. So it follows the pattern we have up here. Just like we have, let's compare this here. Looking at this problem, this exponential portion, the exponent 3 is what the log is equal to, just like our exponent 2 is what the log is equal to. Very good. The base is 2 in this case. In this exponential expression, our base is 7 in our exponential portion here. And then we have of 49. And in this case, it was of 8, where the exponential portion is equal to 8. Ours is of 49, where the exponential portion is equal to 49. So that was a good check. Let's do another one. What if we have 18 raised to the negative 2, and we say that is equal to 1 over 324. Okay, now keep this in mind. This is a review, in this case, of writing powers, right, where you have a negative exponent. So if I were to simplify that, that would be 1 over negative 18, 1 over 18 to the positive 2, or 1 over 18 squared. And then 1 over 18 squared would give me 1 over 324. So that's where that's coming from, all right? That's a review of simplifying negative x expressions, or simplifying exponential expressions with a negative exponent, rather. All right. Now, let's write this again. We have log, and what's our base? 18. Okay. Now, of log base 18 of what number? What this exponential portion is equal to? That's 1 over 324. Log base 18 of 1 over 324. And remember, it's equal to the exponent, which is negative 2. Very good. Let's do one more. We have 9 to the negative 1/2. I'm just giving you different examples. It doesn't matter if the exponent is a positive whole number, a negative whole number, right, or a negative fraction. You still follow the same process. So Yeah, we have that is equal to 1/3. Again, 9 to the negative 1/2, right? You would rewrite that as 1/9 to the positive 1/2. Whenever you have a number raised to the 1/2, that means you take the square root of that. So 1/, the square root of 9 would equal 1/3. That's where that's coming from. So let's go ahead and simplify that. We have log, and what's our base? Right, 9. Log, let me erase that. It's a little too close there. Log base 9 of 1/3 log base 9 of 1/3 equals, and what does it equal? The exponent, negative 1/2. Some people like to always write what it's equal to make sure that they don't confuse the exponent with the other portion. You know it's always going to be equal to the exponent. So we're looking pretty good. Now let's move to, again, now we're going to rewrite the logarithmic equation, and we're going to rewrite that as an exponential equation, okay? So let's begin. Let's start with log base 14. So let me go ahead and write that. We have log base 14 of 196. And that's equal to 2. And we're going to rewrite that in exponential form. So what's our base? This is how you start it out. You ask yourself, what's the base? Right? We know the base is 14, so we know we start with the base. What's our exponent? It's what the log is equal to. So it's equal to 2, so we have 14 squared. And of course, what is that equal to? That should equal 196. So if you had a calculator or something and you squared, you take 14 squared, you're going to get 196. That's how you can check it. All right, let's do another one. So let's say we take log base 3 of 243. Log base 3 of 243. And we set that equal to 5. Now, let's rewrite that as an exponential equation. What's our base again? Our base is 3. And what is it raised to? It's raised to the exponent here, which is 5. And what is it equal to? It's equal to 243. Not complex, you just have to know what you're doing. And we're going to do one more. All right, let's take log of base 243. Log base 243, let's say of 3. And we're going to set that equal to a fraction, 1/5. Now, it doesn't matter. It's the same process. If your base is smaller, a small number or a large number, if your exponent is a whole number or a fraction, it does not matter. You still write it the same way. So what is our base? 243. Let me rewrite that just so it doesn't look like a 9. I was looking at that number. So it's 243. All right. So our base is 243 raised to the exponent. What is that? 1/5. And what does it equal? It equals 3. Equals 3. Just like 3 to the 5th power raised to the 5th power equals 243, this says the 5th root of 243 equals 3. What that means is, what number can you multiply by itself 5 times to give you 243? Well, that is 3. Okay. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.